Miles beneath the surface, human civilization relies on energy trapped in a world of absolute darkness. This creates a logistical hurdle. We are entirely dependent on resources located in a domain that we cannot see, touch, or directly measure. It is an environment defined by intense tectonic weight, where fluids move through rock pores at a microscopic scale. For over a century, the challenge for geologists has remained the same. How do you navigate a world that is effectively obscured from human sight? Historically, this lack of visibility meant that every drilling operation was a high-stakes calculation against an unpredictable environment. To manage this risk, experts spent decades piecing together isolated data points to form a best guess of what lay underground. Analysis began with physical core samples, cylindrical fragments of rock pulled from specific depths to represent thousands of feet of geological formation. Geologists then used these fragments to draw 2D contour maps, attempting to extrapolate the shape of the Earth from a handful of static numbers. As drilling reached deeper and more complex reservoirs, these fragmented tools could no longer keep pace with the massive volume of data generated by modern operations. OmniPetro was designed to replace these fragmented snapshots with a continuous, three-dimensional digital representation of the subsurface. The process begins by sending acoustic seismic waves deep into the crust, using the reflections to scan the rock layers like sonar. By calculating the transit time and intensity of these echoes, the system builds a wireframe skeleton of the underground architecture. This mapping identifies the boundaries of the reservoir and the exact location of tectonic faults before any equipment is deployed to the site. However, a structural map is only the first step. It shows the container, but it cannot predict how the fluids inside that container will flow once production begins. To account for that movement, OmniPetro integrates its structural skeleton into a reactive simulation called the Earth model. The system populates this model with historical well logs and petrophysical data, defining the specific properties of the rock itself. It then adds active variables, monitoring shifting pressure levels and the movement of oil, gas, and water in real time. As production continues, the Earth model constantly updates its internal calculations to match the changing conditions in the field. This continuous feedback loop reveals how fluid movement connects separate layers, showing relationships that were previously invisible on a static map. By linking these data streams, the system moves the industry away from static interpretation toward a reactive, simulated environment. Managing these thousands of shifting variables exceeds the limits of manual calculation. OmniPetro uses geological AI to scan the entire data matrix for subtle patterns and structural anomalies that a human analyst might overlook. The AI calculates the probability of finding hydrocarbons and identifies high-risk zones, providing a mathematical basis for every drilling target. While the AI processes the mathematics, human experts remain the final authority, using these insights to verify the model and set the final strategy. The subsurface is no longer just an unpredictable dark void. It has become a high-fidelity digital network of information. This level of clarity reduces the margin of error, allowing engineers to base their decisions on verified data rather than geological estimation. OmniPetro provides a unified digital representation of the underground world, giving the industry a way to see into the dark before the first drill bit enters the ground.